About the implementation of linked list. So far we have seen about the different operations. So how do we do the insertion, deletion and the display operation. So now we will see about how does the implementation of the linked list happens. So we need to specify what are the header files that are needed to start with. So we need to have an IO stream. So this would help us to take the input from the user and display the output. And then hash define is whenever you need to replace a value with a variable. So whenever a null variable comes, which will be replaced with the value 0. And then we need to specify the structure, because list is the collection of nodes. So as it is taught in your theory class, so every node, it carries a data and an address. So data, it holds the actual data elements, and address, it holds the address of the next node in the list. And then we need to declare a class. So if at all you need to use a class, you can use it. So otherwise, if you are comfortable with only the function, you can go ahead. So class declaration, it follows with keyword called as class and then followed by the class name, and then specify what are the header files. So as you all know, that class is the collection of data, members and then the member function. So here we have a head and a last pointer variable to keep track what is the first node and the last node of the list. And then comes the constructor. You all know that constructor, it takes the same name as that of the class name. So here the class name, what I have used is link. It takes the same name as that of the class name. So this would help us to initialize the value for the variable. And then specify what are the member functions. So we have a make node function, search function, add first, add mid, add last. So these all functions would help us to add the element at the beginning, middle and the last position. And then the delete method, this would help us to delete a node from the front, and then the end, and then this would help us to display the elements. So as I told in the introduction of the linked list, so before we begin with, so we need to, before we perform any insertion operation, we need to create a node with some data in it. So this make node function would help us to create a node. So this is how we need to specify, which is a new node which is of type list. So list is already, we have seen that it is of type struct, because the node what we are going to create, it carries a two part. So one is a data part and then the address part or the next part. So here we have an operator called as new operator. This would help us to allocate some memory for the node what we create. So new node is the node what we create. As I told that the data part is equal to n and the next part is equal to null. So once we have done with, we need to return what is the address of the new node that is created. So and then I've written a small function that is called as the search function. So search function is mainly used when we need to perform some operation somewhere in the middle. So when you just want to add a node in the middle, when you just want to perform the delete operation, this search function will be used. So because as I told that linked list is always the access is sequential. I need to begin with the head node to find out where the first node is actually stored, first node to know where the second node is actually stored. So initially we need to declare a pointer variable, and we are going to store just the address of the head node, and then iterate through a while loop in order to check where the data is actually for. So once we have got the search data, we will be able to return the address of the element. And then there comes, how do we do the addition of a node in the beginning of the list? So here we need to get the element to be added, and then declare a pointer variable list asterisk np is equal to make node of n. So now we are calling the make node function, and we are going to pass n as an argument to this function. So once the make node function is called, a new node has been created. So in this condition we need to check that, so what will happen if your list is initially empty. So we put an if condition and check if head is equal to null. So if head is equal to 0, the new node what we are going to create, both head and the last pointer variable will be pointing to the new node that we create. So otherwise we have some list of nodes, means again we need to create a node with the name np, and then np.next, that is the address part of the new node must be updated with the address of the head, because head currently it holds the address of the first node. So now I need to make np to point to the first node, and head now must be updated with the address of np. So this is how we do the addition of the insertion of a node in the beginning. Then how do we do the insertion of the node in the middle is, again we need to invoke a search function. So why do we need, as I told, that whenever we need to find the position where we need to exactly perform the insertion, so for which we need to get the search element. So before which data, say for example I have 10, 20 and 30. So before 30 I need to insert a new element. So to this function we need to pass 30 as an argument and put an if condition and check if temp is equal to null. So if the search element is not found, we may not be able to perform the insertion. So otherwise create a np pointer variable, call the make node function, and to this function you just pass n1 as an argument. So now what we are supposed to do, so np is the new node what we created. So the address of np must be updated with the address of temp. So temp, it contains the address of the search element, so which is now copied to np, and temp dot next must be updated with the new node what we created. And then we have the last function which is called as the add last function. So to this function we are passing n as an argument. So here again we check if head is equal to null. Again, if the list is empty, then the new node what we have created, both head and last, must point to the new node that we created. So otherwise the last of next, that is the address part of the last, must be updated with the address of the new node that we created, and make the last pointer variable to point to the address of np. So this is how we need to do the insertion of the node in the beginning, middle and at the end. So is the case with the deletion. So if at all we need to delete a node in the front node, so in that case we need to store the address of the first node to some temporary variable. So here we are storing the address of head to some temporary variable and update head with the address of the next node. So once you're done with, we can, in C++ we have the delete method to remove the node. And so is the case when we are going to remove the last node. So once we remove the last node from the list, I need to make the previous node of the temp.next must be pointing to null. So this is how we need to perform the deletion of the node at the end. And then the last is the display function, and again check for head is equal to null. So if it is so, then the list is empty, otherwise, and run through a while loop to print the values. And we have a main function, and in the main function use the switch case, and if it is case 1, and since I'm getting the element from the user, pass the element as an argument in the add first. And in the case of the middle, I need to pass two arguments. One is before which element and the data which has to be inserted, and then the last, and then invoke the delete front and the delete. So we need to iterate through the while loop. So now we will see about how this code works. So the first is the add first element. This would help us to append add an element in the beginning, and again I give add first. So now the element 20 is added before 10, and again I give add first 30. So 30, 20 and 10. So now we will invoke display function, and we see that 30, 20 and 10. So now I need to invoke the third function, add last. So the last element is 40. Again we see that 40 is added to the end of the list. So add mid is I need to give the before element. So before 10 I need to add 5. So now we see that. So this is how the insertion would begin. So now we will see that. Okay. Again we see that how does the addition works. Again I have added 30, add first, added 20, and then add first 10 is added to the list, give sixth option. Now I need to add an element in the last. So 40 is added in the last, and I need to add an element. Before that we need to perform the display operation, and then add mid. So before data is 20, and which element you need to add. So 5 is added. So now invoke the display function. 5 is added before 20, and then we need to delete an element from the last. So here we see that 40 is removed, and if I need to delete an element from the first, the data is 10, and we will continue to remove an element until the list becomes empty. So the message what we get is your list is empty. So this is how we need to do the implementation of linked list. Thanks for watching.